Okay. The first group, Mansi and the Jagriti. So you guys start. No problem. Okay. Are you sure? And Michael, you are like because you are PhD, intentionally assign the one student the other. Okay, I think that you are because you are PhD student, you are able to do the research by yourself.
That's fine.
And group number 3, Parma and Shiva. So you are Parma or Shiva. So do you meet the Parma?
Yeah.
Okay. So I think I assigned you to this group last, right? If I remember correctly. And Saira, Manesh. Why don't you call to come? Yeah, why don't you ask them? Come back. Oh, they are coming. Any others outside? Divya and Shreya. Okay, you are ready? You guys are doing?
We'll start.
Okay. Harsh Kumar and Venkata. Indusa and start. So you do not know?
We have not started.
Selva, Siddharth, Selva. Okay. Navina, Udaya. Navina, Udaya. Battery, Bella. And Bhavana.
Started.
I started, okay. The Gidok and so on. Okay. So let me check again the Sairam and Manish. So you guys already start, know each other?
Yes.
Yeah, okay. I want to make sure your group is finally formed. The Harsh Kumar and Venkata. Okay, so you as a team. And Siddharth, Indusa, why don't you send a message
Yeah, sure.
to Siddharth, then have a meeting, then do the project together. And the CCTV, if no response, then I'm going to change the topic for you, okay? Navina
Yes.
and Udaya.
Yes.
So you guys are team
Yes.
each other, okay? So then no problem except the Indusa your team, okay? The other teams finalize. Then why don't you? So in your page 3, so first you need to install your selected data. Some of the students already did, but if you just research from their website or the document, so please download and try to install. It is true. It is. I understand. Some of them is they do not provide a reliable version. So it works on the Linux server, but they do not support the Windows-based. So try to install the different OS, or you can use the virtual machine also. If you need to use the Windows, or the Linux, or the Unix-based operating system. Okay. Then second thing is the familiar with the functionality. So they are not like their interface are not like the SQL or relational database. It's not very user friendly because they try to simplify the interface. They just provide the API only, even without share. the interface. Unlike the HBase shell, the last week you practice the HBase shell, so you can scan, create a table, and so on, like that. But unlike that, some of the NoSQL database does not. They do not provide. Or some of the databases just provide the graphical user interface. Or DynamoDB, so you can create through the web interface by clicking. And you need to find the way to, like the Java, the API to access your DynamoDB, or the similarly you need to find. First, then second thing is familiar with the interface and how to create. But I strongly suggest in your documentation, keep recording, keep documenting, such as the installation and the functionality. Then later, the other student can refer your writing on, okay, like the manual, okay. So it can be used for the others. So why don't you keep documenting what you are practicing and use the realize in your selected database. The third thing is find the data set, okay. So such a data set, also you need to consider what kind of application you are going to implement. Whether this is just the data, like the selection only, or the data analytics. I think that you can think about the data analytics part, like the recommendation system or something. For example, I took the Python class. I know very well Python. So Python provides something, the library or the package like the PyTorch or something, the TensorFlow. So you can combine such a thing with the NoSQL database. So for analysis purpose. Then I think pretty much that's reasonable for trying the ASE conference or something like that. Not just selecting the one data, then that's it. Okay. So find the data set as well as think about at the same time, think about what kind of the application you are going to implement. Then the upload, the create. Based on that, you need to model your database. Like sometimes your data set combines several different data sets. You guys can normalize if needed. Then select the row key or the primary key. Sometimes it's a different name of the key. You need to model based on the modeling technique that we have discussed a lot. The several weeks and today, so you need to model. Mostly it's a denormalized grouping based on your requirement. Then finally implement. So at the time you need to check what kind of API or interface that your selected database provides. So you need to select the programming. So it's not a simple process. So then do not try to implement it in huge the database application. Instead, first try one or two simple. Then if successful, you can combine. Then it is better if you have the user interface like the convenient way. It's not you don't have to first focus on the fancy, nice the user interface. So, but it would be better if you can provide such a user interface. Then you will have the one database system based on the NoSQL database. If needed, you can combine with the Hadoop, also like the MapReduce program as a backend processing, or the Spark. If you know, if you already took the big data course, so you can combine such a programming framework with your NoSQL database. So many of the NoSQL database support the Spark, the Spark with the Python. Then it can be much easier to implement such a thing. Then that should be done by the November 2nd, right? November 2nd. It's the week away, right? Next week. So we will see. Next class, we will check your progress and whether we are going to extend or not. Because if we extend one more week, so I'd like to see your final presentation, the writing of the poster and oral presentation in the regular semester. We can share. Or we can have the kind of workshop. I did many times before, but not last semester. But we can, within this group, we can display the poster and then invite your friend and the other faculty to review the research, the poster, then the award, first prize, second prize, something like that. So I'm thinking, but please go ahead. Anyway, next week I'm going to check your progress for each team. Then we will decide whether, but don't expect the extension of the keep working. In case your selected database does not support a lot of functionality, so with my approval, you guys can select the database selected by another your team member. Okay, but please contact me as soon as possible in case you need to change your database. Okay, that's good. So far we have compared the NoSQL database model based on the ER modeling, the conventional database modeling, but we'd like to see the practical part from the HBase. There's no foreign key, no join, I already explained. So no cross table transaction, we already understand. Then how can we address such a thing? Denormalization, we combine, grouping the attribute. Okay? So there are two ways to address such a thing. One is roll your own join. What does that mean? It's application side join. Instead of the server side join using the secondary index or the hash join, but by yourself, in your application program, you can, for each key or the value, you can check the if then else. In case of this one, you can change the value like that. Most of the case, that is not such a huge table by huge table join. Instead, a small table. And the 1 means CS, 2 means CE, 3 means EE. Then, when you process for each record, so this is the major. So 1, 2, 1, 1, 2. So for each one is a CS. You can replace. Okay. You can do this one with the join operation, but instead by yourself you can implement the join. Or when you design this one will be part of this. That is the denormalization. Okay. What is a denormalization? I mentioned the denormalization a lot. So actually we did the denormalization during the relational database model before. Anyone? When do we need to use the denormalization in relational database model? I think you guys are taking the advanced database course also, so a little bit confused. I do not learn the normalization even yet. So normalization means segment. We split to remove any redundant information. It's kind of standardization. Student table only keep the student data. And the professor table keep the only professor information. Like that, separate segment. So then, because of that separation, normalization, we need to join. But sometimes we need to denormalization, means combine into one. Okay? Denormalize, opposite grade of normalization, combine into one. But when we combine, we have an anomaly problem. So I'm not going to explain here. It's something problem, redundant information then. But why do we need such a denormalization? Performance. To avoid any such a very expensive join operation, so we try to keep the data inside. So that is a denormalization. Okay, so we are going to use such a technique, denormalization, for the HBase, the modeling. So let's take a look at this, the concept, the ER modeling. So we can normalize altogether, or based on band, or based on show, or based on even band and show. So we can actually denormalize based on band. So we will see the different types of denormalization here, like this one. For example, band. If we try to keep the band, which means our most of the application access through the band. I'd like to know the number of shows. So, like, what kind of band is most popular nowadays? I do not know. I'm not expertise on music. I know only the 70s, 80s, or Beatles. So, but anyway, for each band, I'd like to show the band. For each band, I'd like to know the shows that happen in this concert, like that. At that time, we can denormalize based on the band. So T is band ID, then show 1, 2 problem. How do we know? How many? So it's a repeated. But it may be possible in using HBase, such a non-schema list, the NoSQL database. Or we can have such a list, like using in case of JSON, we can actually inside the show and the list of show. Okay, so or if you're familiar with Python, we can use kind of dictionary type of the list. So we can use this one also. But the problem, we no longer keep the meaning of the show. It's just a list. Okay. Then, what if our application focus on the specific show, then we'd like to see number of bands. Then we can take the show as a master table and denormalize, combine into the show. Or even band show, band ID and show. So specific the show, okay? Not the number. Specific one is our focus, then the combine band information and the show information together. Okay? So this is one of the example of the denormalization. So there's no general rule, but we need to focus on the requirement. What is the purpose of the database? Then the denormalize each one. Then one more thing. In HBase model, what will be the key? Because the data that will be stored based on this table model will be sorted by the key. So we can utilize such a key to find or range query or something details query based on the key. So be careful to select the key of that. So we will see the example of the HBase case. So in this case, some of the list is not predefined. Okay, it's just a list of the data. So instead of such a list of data, why not include the entity? It's called a nested entity. That more makes sense. We can keep the meaning of this entity. So it's a nested entity. So for example, the band shows the data type, but this is another entity. Then we can keep the meaning, semantic of the show when we denormalize based on the band. Okay? But this is not possible in relational database. Okay? If you remember the normalization process, the first normalization does not allow this one. Why? Because the idea of the relational model is first condition, the constraint is primary key. Through the key, we are going to find the data very fast. Also, we can keep the consistency. But if we have another table inside, it's really complicated. Even processing query optimization is much more complicated. It's not one level, it's a two level. It's the exponentially increase the performance overhead. So think about the drawing with the nested table. Then it will be you cannot get the benefit of the relational database. So relational database does not allow such a thing, but NoSQL database like the HBase allow the nested entity. Okay? So you can scan the nested entity in the HBase. So this is the example of the nested entity. It has also key. So using the key, you can define the value. So finally, when you access the value of the nested entity, table name, key, row key of this table, and nested entity, their key, finally you can access the value. Okay. So this one is like the column. You can consider as a column, but that column based on the nested table. So this is the example of the show and the band. The band is the master table, and it has the row key as the band ID. Then the show is the column. Okay, that is identify the show ID. Then each show has such an information. Okay. So still it keeps the key and value. And inside the value, it also has the number of key and value format. So key here, the key value container format. Why not? Number of the entity. It is also possible. So band and number of entity inside. So if you cannot imagine exactly what's going on the nested, think about the JSON format. In the JSON format, you can actually define a number of the key and value. So that is the idea of the nested entity. Okay. So it is suggested for the column name start with such a two kind of prefix to identify easily, like the S for the show and but not required. So this is the example of the number of the nested entity for the HBase table. So you can design such a way. Not only just one level, you can do the second level, as many as possible. So then at the time you need to use the row key of the master table and the row key of the nested and another row key of the nested finally to access the value. Okay. It's a two level and okay. Then column family in the HBase actually the unit of storage. So you can take the, for example, for HBase table as the column family 1 and column family 2, column family 3. This column family will be stored at the one region server and different location. So by the row key. And this one is another region server by the row key, which means it can be distributed. So when you define the column family, so it will be better. It's like a partition. So you can think about that partition. Then that is sometimes called the namespace, different location. It's almost the same meaning as the partition and namespace. So when you design the column family, you can also consider such a the partition and the different name service. Okay. So this is overall the schema that you can create for the show, to show the HBase schema. So master table, and it has a low key. It doesn't have to be one, the attribute is a number of massing that I introduced here. That is combined, because that key can be eventually used for sorting and access the data. You can implement the reticule. Then for the column family, it's a different location, which means the partition namespace. So you can consider the different location like the parallel processing and distributed data. Then for each column family has a number of column. That column also can be nested entity. And nested entity means it has its own low key. It doesn't have to be only one, it can be also multiple. Timestamp is one of that example. Timestamp has the different version. So one column has a different version. So it's a nested. So you can use such a nested. Okay? So which means when you access the specific value of the HBase table, so key, low key, column family name, column, or this is column name, and there the key or the version, and the finally value. Okay. So this is an example of the XML, but I think right now JSON. Using the JSON, I introduced the JSON last, I think, a couple of weeks ago. You can easily understand the semantic meaning of the HBase schema. Okay, so let's take a look at the example of the HBase model. This is ER modeling for the applicant and answer. So which means for each applicant, there is a question answer ID, number of answer. Okay, then applicant ID, the foreign key, and question number or question ID, and their answer and the date, like this so on. So basically each applicant a number of answer. Then for this one, if we denormalize, so it can be like the answer by applicant for each applicant, and we can have number of answer. Still, we keep the order 1, degree 1, which means it's a linear. The more data you have, just increase the time. So that is the linear. Not linear. This time it's not linear. Because we know the ID and the answer question ID and find the value. Using the key, we can directly find. Okay? That is the reason it's a complexity. Even though we denormalize, we can keep the order 1. In terms of legal notation, it's the 1. 1 means it's a fixed time, just a fixed time. So it's the best one. So in terms of time complexity. Okay. What does it mean? We can get the answer history for free. Because it is ordered by question ID, that's based on the history. So first answer will be earliest one. Second answer, the next. It's actually history. The historical data for free. So because of this one, you don't have to sort again. So this, if we see the HBase structure point of view, is the key AP123, the 456 is application ID. Then the name is this one, so for each applicant, and the question is the question ID. Answer ID is 1, 2, 3, 4. It's in order. Okay, you can have a number of them, like this one answer. Okay, this is the exactly it's a high level view for the physical storage on the HBase table for the denormalization. That doesn't mean such a denormalization HBase schema design is the best one. For example, the aggregation, like for example, the value for the specific question ID is the problem. Like for example, question ID 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4 somewhere here. If you wanna combine, aggregate such an answer problem, you need to access all of this. Okay, So that is the reason at that time you need to denormalize the different way by the question ID. So this is a question ID and the answer. So you need to denormalize a different way. Then some of the NoSQL database support secondary index, like the DynamoDB support the secondary index for sorting key, using the sorting key. And some other cons. And the second example, this is the first example is one-to-many case. So this is the many-to-many. So this is a junction table, it's an in-between table for many-to-many. The one user has the many messages. This one message actually accessed by the many users. It's a many-to-many. So junction table has the no other information, only the message ID to here, user ID here. Okay, so in this case, so there might be no problem in terms of the relational model. So to access such the data. So 20 must listen to message. How can we do that? 3 table join. We need to join this one. 3 table join. Then the top, even top 20 is not that simple. Some of the DBMS, the DMI does not support the top because actually you need to do order by and make the view and select the first 20. That is the top 20. But even using the top 20, it takes a time. But it is possible. This is what the relational database model is doing. So in the NoSQL database HBase, we can we can apply the denormalization. So by user, okay. So for this kind of query, so we try to select for one user 20 recent message, which means the user can be a master table. Then denormalize the message, merge the message for the user. So each user has number of message, which means one message can be created multiple times. Redundancy. That is not allowed in the relational model, but here, NoSQL database, we sacrifice such a redundancy. Instead, we will get the performance to access such the information. How? We can per user. This is already sorted. Like the history, versioning, timestamp. So we can, in this case, if this one is ascending, just from the bottom, the ascending order, take 20. We don't have to sort the data. We don't have to merge the data. Just for each user, for each data, we can access the first 20. That's it. So that is the reason. Some denormalization provide a better performance. We can use such a denormalization in the HBase. What about the date? Okay, I wanna get the specific the message for the specific date. You can denorm. Definitely, same message will be stored several times. Okay. It's redundant, but we can denormalize by date for message. So then when we access such the message by specific date, we can get the message from the row key, column name, and the key. Finally, get the data value. So this is how we can use the. If in case we have the column family, we can separate each denormalized message for each column family. Then it will be stored differently. Then we can get the benefit of the distributed data. This is the high-level view of how we can store the data after denormalized for many-to-many. So this is the user ID for row key. And for the first column family is the information about this first column family, and second column family is denormalize the message. So message, message, message in order of what? The timestamp. Okay? And this is the for specific date. The key is the date. Okay? And the message. So definitely it's the redundant, but we sacrifice such a redundancy. And so on. So we can have the number of the row ID. Flurry is a website for data marketing purpose for specific device, like the Android device or even the specific device. What is the mostly used app, what a website, they provide such a marketing data. That's a Flurry website. I think the data is not working, so you can go to the flurry.com, then you can get the more information about that. So we will use such a Flurry data for the HBase schema modeling. So in this case, we can denormalize for each session per device. So for the device ID, then the device information, then what the page, which the website visited, that is denormalized. The session information. The key of the denormalized session information include the session ID, fragment type. I do not know what is a fragment type, and but the report data. So use the data. This is a value. So we can search a denormalize. What if I need something indexed? So this is another example of through the for each IP address we have the for each IP address we have the number of hosts. It's kind of the IP is indexing to find the host name and so on. So to do that, we can actually use this IP address as the key. Okay, then it will be sorted. So we can use such the low key as the indexing of the data. So that's the idea. So by summarizing, there are some kind of guideline or suggestion of the HBase schema model. So as you can see, it's not only for the HBase. HBase has some different, but usually HBase database is the general key value based NoSQL database. So you can actually if you are using if you selected a NoSQL database based on the key value model data type, you can find a similar functionality or the model, then you can apply such a thing. So as you can see, the low key is very important because that is the only way to create the index. Because data will be sorted by such a low key. DynamoDB slightly extend, as you have seen. The DynamoDB first part will be used for the partition key. Here partition is based on HBase is based on column family, but the DynamoDB used the hash function for uniformly distributed, but eventually they applied the throttling for to avoid any skewed data. But it's based on the partition key and sort key. That sort key is anyway the key. So key design is the most important part. From the first example, so you can design for the question, not answer, which means what depending on your query. So which one will be the master table, then which one will be denormalized. So what you are interested in your query is the master table. So design the question, then number of answer. Mostly one side is the master table, then the denormalized the entity table is the answers, one and many, like that. But in case of many to many, you allow the redundancy, but the many different. It's the same idea also. So like this one, the for user and denormalize. That means when you denormalize, so extreme case, this one the millions of users and one message, okay, or the one user and the millions of the message, depending on the requirement. So if you are obsessed, so you'd better use the number of the which one is better? Bigger size of the master and the smaller size. So it is better to have the bigger size table, the master table, than a number of denormalized. If this one is too big, like the extreme case one user and the millions of denormalized, you cannot get the benefit of the denormalization. Okay? And compact. And that means that we try to utilize the column family. Column family will be stored together. Columns in the column family stored together. Then, if we allow the nested entity as a column family, so this is a kind of one table in the region server. As you can realize, as we have seen so far, so it's a row-based. It should be meaningful for each row, which is called the row atomistic. Okay. So still, do not rely on the primary key concept used in the relational database. So any attribute can be low key based on your requirement. So it can be flexible to identify the low key. So mostly when you denormalize data, it's as much as the combine, okay, to make the compact. That means it's a kind of pre-aggregate the data. Okay. I think pretty much that's the end of the schema design. Okay. Today it's a little bit earlier, so let me stop here today. Okay. Any questions so far? So HBase is kind of the typical NoSQL database. So it's still being used a lot in industry. One of the reasons is the first NoSQL database in the market, and it works very well for the key value. So for example, think about the log style. So if you try to use the HBase for the existing relational database, I don't think you can get the full benefit. So as we discussed a lot, NoSQL is not the solution of the relational database. It's not up the replacements of the relational data. So HBase or the NoSQL database has its own characteristic for huge amount of data, but simple query like the Amazon mostly find the item. Okay, then at the time you can create the HBase or Dynamo, the key value NoSQL database to support very fast response time that cannot be addressed by the relational database. Okay, that's a backend. But you may lose something, consistency or redundancy, and that to get the benefit of such a performance, so you need to sacrifice. Okay, next week we will see another type of the NoSQL database, which is also the most popular nowadays. It's the MongoDB database, so which is the typical example of the document database. The reason is that actually our data nowadays is really like the document, because we are very familiar with the table style, the relational database. Actually, they are coming from the document. Document is not always this kind of document, but your programming file is a document. Your text file is a document. HTML file, website is a document. From the Google actually combine to collect all the document. It's HTML file, it's a tag file. So MongoDB is if we store the data into the JSON format, or for example the Python, your data is the dictionary or list or vector that can be easily managed by the MongoDB. So we will see what is the MongoDB, how we can use the MongoDB. So please bring your laptop. I don't think it will take a much longer time to discuss about what is the MongoDB, because we have discussed a lot the base of the. So we will do the exercise lab together after the class, tomorrow next class. So next week. And also I'm going to check your progress of the project, the beginning of the class. Any other questions? It's getting cold, so I'm not going to allow any excuse that I got cold, high fever, something like that. But first, take care of yourself. That's the first thing, and we will see you the next week.